types of communication, what is meant by communication, topologies, okay, and types of network, LAN, MAN, CAN, WAN kind of stuff, about NICs, MAC addresses, how to check MAC address, how to check IP address, MAC and IP address differences, different cables we are using, UTP, STP cable, fiber optical cable, coaxial cable, different devices like hub switches, routers, and modem, their differences. Okay, what is about a Wi-Fi router? How we are connecting to internet? Okay, so that is also we discussed, and about IP address, IPv6, both we are completed. So in your notes, some few points also there, like a entire network range, total network, and what is subnetting. Okay, those things also there. I believe that's a point. And also we discuss about a private IP addresses. Today, what we will do, first we'll start with this once again, private and public IP addresses, and what is this NAT and PAT. And then we'll see how to check the IP address and how to configure IP address manually, automatical configuration, where we are selecting those options. Okay, and IP address also we'll discuss. Then we'll see about a OSA model. In the OSA model, lot of things are there: protocols, port numbers, TCP, UDP, and other things also. So we'll try as much as we can able to complete today. Okay. So then you got a time tomorrow, day after tomorrow. So you'll concentrate on what we have discussed on service desk and hardware and networking and troubleshooting questions also. I already shared some documents. Otherwise, I will share documents which is having troubleshooting questions on both hardware and networking and ticketing related questions also. Okay. Read at least 2-3 questions every day. అలాగే సరే లాక్పడుతుంది. Okay. What we discuss is where are we right? Private and public IP addresses. What is private network? What is public network? Already we know what is intranet, internet. What is internet? Networks of network. Okay. You want to access a google.com, facebook.com, youtube.com, anything like you are accessing through internet only. Okay. Without internet, we can't able to access. Without internet, we can't able to access google.com, facebook.com, youtube.com, because these are all at different servers. Okay. So google.com server is there, youtube.com server is there, facebook.com servers are there. So these are in a different locations, not in your office, not in your home. Somewhere it is located. It may be in Hyderabad, it can be in Mumbai, or maybe it is in Singapore, it can be in California, it can be in Australia, like that. Okay. Those servers are available through public access. So you want to access those things, you need to connect it to the internet. Need to connect it to the internet. Through internet only we can able to access. Okay. So internet is a public network. So publicly available, internetly available things you have to access, then we need to connect it to the internet. How to connect it to internet? First, you have to connect it to the internet service provider. The internet service provider can be Airtel, or maybe a Geo, or maybe ACT, or organizations have a separate service providers. So organization related service providers. Of course, Airtel also is providing, ACT also providing for organizations also. And separately, only for organization service providers also, like HCL, Tata, what we say, Ticona. Okay. So there is a different organization purpose on the internet service providers. Okay. So anyway, what it is, guys, in your home or an office, you have a systems. Okay. Either desktop, laptop, mobile phone, or a servers inside your office. So you are communicating within the organization. You are communicating inside. Okay. To communicating inside an office, that is what is the right. So of course you have a system and you want to get connected and communicated. So then the systems need an IP address. Without IP, you can't communicate. But what is your area of communication? Within your LAN communication only, within your network, within your private network it is. So what IP address, what type of IP address we use? We use a private IP. Private IP address within your network. Okay. So this is also called an intranet. So for example, in our office, we are having a laptops, desktop is there, and there is a servers also there. Okay. So when we are connecting and communicating, so within our office, within our one private IP address, we are communicating. So we don't require any internet to communicate from my laptop to another laptop or another desktop and another server. Okay, but what we don't require is internet is not required. Routers also not required because we are all connected in the same segmented network only. Okay, so that is our private network. So in a private, we use private IP addresses. So these are the private IP address ranges are given. From class A, only one single network is given, only 10 network is given. So 10.0.0.0 network is given. Okay. So total 10 network is there. Okay. So if you use 11, it is a public. If you use 9, it is public. 10 is only the private IP address from class A. From class B, there is 16 networks are given. 16 networks are given. So 170.16, 170.17, 170.18, 170.19, and up to 170.31 it is given. Totally 16 networks are there. See that? These two portions are network portions, right? This is the host portion. Okay. So this is a network. So only it is a change in the network portion. This is one network, this is another network, this is another network like that. So totally 16 networks are given. If you take 170.15, it's a public network. 170.32, it's a public network. Okay. In between, that is 16 to 31. It is all private network IP address only. Okay. And from class C, 256 networks are given. 192.168.0 network. 170.168.1, 192.168.2, 192.168.3, 192.168.4, like that up to 192.168.255. These are the total 256 networks from class. Okay. So this is entirely network version. So where it is changing 1, is 0, 1, 2, 3, 4 up to 255. Each one is one network. This is one network. This is one network. This is another network. Okay. So here I've written also what is the network means. You can, here it is, one network. So it's a class C network. Okay. So class C IP address means first three portions are network portion. That last one is host portion. So this is the starting one. For example, starting one. 192.168.1.0. This entirely network part. And this is host part. But host part is 0. Okay. It means if you in a binary, it is 8 zeros. Single zero means in binary 8 zeros. So there is no ones in it. So this is what we call it as a network ID. This representation of a network ID. Network or network ID. Okay. So these network IDs we can't assign to any devices. We can't assign network ID to any devices. First one. Second, what is the next number of after 0? It is 1, right? So 1. So if in binary also you can take 0, 0, 0, 0, 0, 0, 0, 1. Okay. So that is in a binary, right? So in a host portion, there is a number. Here, in a host portion, it's a 0. So completely 0 host. 0 host, there is no meaning. That's it is network ID. We can't assign to any device. But here it is, host portion is 1. Means you can say like number 1, number 2, number 3, number 4, like this 1. So this is the first valid host ID. This is also same network, this is address, this is also IP address. But thing is, this is network ID, we can't assign to any device, but this is we can able to assign to any device. Okay. And in that series, in the series, it's the first one. So that's it is first valid host ID, IP address can assign to the devices. Then after one, it is 2, 3, 4, 5, 6, up to 254. Up to 254. In the 254, it's like a called as last
Sir,
value.
your
So
voice
we
is
have
not clear.
255 also there. If you
Sir,
see
your voice
255,
is.
if you convert it, okay, voice is not clear. Okay, what we will do? I will stop sharing. I will mute. Now my screen is visible. Voice is clear.
Yes, sir.
Yes, sir.
Very very good. Very good. So where are we? Yeah. So the last final one is 192.160.1.255. 255 is the last number in one single octet, right? After 255, it has become 0. Once it is become 0, this is become 2. So 1 is become 2. So it is, see, the network portion is changed. Earlier it is 1, now it is 2. So different network, means mesh network it is. So our network range is from here. So starting one is this one and ending one is this one. Okay. So from 192.168.1.0 to 192.168.1.255. This is a total one single network. Okay. In the last one, that is 255, is the 255. If you write in the binary, it is all are ones only. 8 ones are 1, 1, 1, 1, 1, 1, 1. Entire host portion is ones. Means this is a representation of a broadcast. Means all. So okay. So there is no 0 ones there. So obviously it's representation of all. It means it is this IP address is a broadcast IP. Broadcast ID or broadcast IP address. This is also we can't assign to any device. So, but what we can able to assign from this 1.1 to 1.254, this entirely 1, 2, 3, 4 up to 254 we can assign to the devices. Totally 254 IP addresses we are getting. So if you have a network, and you want to configure an IP address, okay, and how many systems are there? How many devices need an IP address? For example, you have a 50 devices. So we are from this class C IP address, we are getting 254. Simply you can use 254, right? So out of 250, 50 are available. Yes, we can use it. So if you are using this IP network, this is class C. If you are using class C, so maximum for any class you take, only single host portion means 254 per network, 254 devices you can connect it. If you have more than 254 devices, for example, you have 300 devices are there, or you have a 500 devices, you have 1,000 devices, then class C is no use. Okay, class is no useful because class is support 254. Then what to do? You go to the class B. Example, you can take 172.16. For example, it's a class B IP address. 0.0. This is a first one. It is called a network ID, which is it's a class B means the first two portions are belongs to network. The next two portions are belongs to host. So entire host portion is 0. It means it is a network ID. We can't assign. Then what is the next one? This is the first valid host ID. In this IP address, we can assign to any device. Can assign to any device. This is first one. Oh, shit. Okay. 172.16.0.2. It's keep on going. 172.16.0.3. 172.16.0.254. 172.16.0.255. 172. So as long as 172.16 is not changing, still it is in the same network only by default. And it is become 1.0. Still it is same network only, same logical network only. Because what is the network portion is 172.16. 172.16 is your network. That is not changing, right? Host is changing. So 0.255, 1.0, these are all host IDs only. Some people believe if the last portion is 0, it is invalid. No, guys, it is valid only. Okay, it is valid only. You can assign it. So it is keep on going like this. Even you reach 170.1.255, it is 172.16.2.0 like this only. So what is the very last one is 16.255.255. This is the very last one. So what happened after this? It is become 17.0.0. See, the network portion is changed here. Network portion is changed here. If the network portion is different from here to here, so it's not belongs to our network. It's a different network. It's not belongs to our network. It is different network. Okay. So what is the just before IP address? We'll see that one 172.16.255.254. Okay. So we'll see this is the last one, right? So if you see 255 means 8 ones, 8 ones. Total host portion is all are ones. It is representation of broadcast. Okay. Broadcast, representation of broadcast. Broadcast ID. Okay, which is also we can't assign to any device, but which we can able to assign up to 255.254 we can assign from 0.1 to 255.254. All we can assign to IP address. Okay, so this is a last valid host ID, or we can say host IP address. Means we can assign to the devices from 0.1 to 255.254. Means 0.1, 0.2, 0.3, like that, 1.2, 1.5, 3.10, 10.20, anything is valid. Okay. So only 176 is same for everything. Okay. So where it is started? From here. It is started from here. You're starting assigning from here. Where it is ended? Here. You can stop assigning after this one. Okay. From here to here is a valid host range. The total is from 002 to 255 to 55. Then what is this? It's the next one. So it's a different network it is. So your network is from here, the check mark to this check mark. That is the total network size. But we can assign IP address from here to here. So you know how many IP address this from here to here. Total valid is 65,534 total range. Means in your network, you have a 500 devices. You can use this one. You have a more than 254 devices. What to do? So if you take class C network, support up to 254, just before we discussed, right? Class C networks, 254 devices support. So you have a 200 devices. You can use class C. 250, you can use class C. But you have got a 300 devices in your network. 400 devices in network, 500 devices in your network. So what is the thing is you have to go to the class B only. That is a basic network architecture. Basic network architecture. How many devices in your system, including desktop, laptop, mobile phones, tablets, or TVs, servers, printers, right? So different devices in your system. Total number of devices. Less than 254, class C. More than 254, go to class B. So what is the maximum range? Is 65,534. So you have a 5,000 devices, 50,000 devices. Still we can use class B. So if you have a 70,000 devices, class B is no useful because class B support up to 65,534 only. Okay, number of IP addresses. Okay, then where we have to go? Class A. Class A is also little similar. It is, so for example, you take 10 network. 10 network. This is a 10 network. The first is one is your network ID, which is we can't assign to any device. So three host portions, single network portion. Okay. Three host portion, single network portion. Okay. So this 10 will start from 10.0.0.1 is the first valid IP address. Means you can start assigning IP address from this IP address. You can keep on going like this. Similar to this, our class B, same type only. 255 reaches 10.0.1.0. Okay, like this. When it will be finished 10.255, 255, 255. This is our last one. Means it is a broadcast ID which we cannot assign. What is after this one? It's 11.0.0.0. Okay, this is another network is started. So as per network ID, it is different network. So our network is ranging from here to here, and 10.255, 255, 254 is a last host ID. Okay, so what is a class C network from here to here? Only thing is the first octet is not changing. Entire remaining is host address, so it will be changes. It go on 1, 2, 3, 4, like up to 255.255.255. This is a total range. But what IP address we can assign from here? We can assign it from here 0.10.0.0.1. From here, we can start assigning to the devices. So you keep on assigning and up to what is the last one in this network. What is the last one we can able to assign is 10.255.255.254. 254. Okay, the 10 is not changing, but remaining is the last one. So this is a total valid host IDs. Host IDs, most assigning IP addresses. So this total range is from check to check. This is total range. Valid host, number of devices, how many number of devices we can connect using a class C, class A, it is, I forget the number. It's around 16 million. Actually, it is around 16 million. Yes. Okay. 16 double seven, sorry, 777 214. This is a total number of hosts we can connect, maximum number of hosts we can connect, number of devices we can connect in a single network. So, for example, you started an organization and there is 70,000 devices. 1 lakh devices are there. 2 lakhs devices are there. Okay. Or maybe a 50 lakhs devices are there. So still we can use class A. 16 million. So 16 million, 777,214. But if you convert in our thousands and lakhs system, it is 1 crore 67 lakhs 77,214. Okay, so that those many 1 crore 67,777. Sorry, 1 crore 67 lakhs 77,214 number of devices we can connect in a single class A. So your network size is more than, your network size means number of devices is more than 65,534. Then you have to go to the class A only. Okay. So this is number of devices. Actually, I started with the private IP and we went to not somewhere. It is actually yesterday I didn't explain that one also. Okay. So this is from class C. So class C, the last one is host portion, right? So these are the network portion. So network portion should not be changed in the same logical network. If different network portion means it's a different network. In the same network portion. Host is will be changes. So this last portion is host. Last portion is host means, so how many octets, how many octets in this, sorry, in this octet, how many bits are there? Maximum number of bits are like a 8 bit. One octet means 8 bits. So it's a 1 octet. So 8. 2 to the power of 8 is 256. And minus 2, 254. Why minus 2? Because we can't assign network ID. We can't assign broadcast ID. That's why it is minus 2. Go to the class B. Class B, 2 host portions. So 2 octets are host portions. First 2 are network, second 2 are a host one, right? So 2 octets. Each octet is 8 bits. Totally 2 to the power of 16. Okay, 2 to the power of 16 is your total range. So it is 65,536 and minus 2, it is 65,534. You know why we are doing minus 2? Network and broadcast. Again, you take a class A. The first portion is network, remaining 3 portions are a host portions. Means 3 octets are host portions. 3 octets. 3 into 8 is a 24. 2 to the power of 24 minus 2. 16 million. 777,214. Okay, like that you can see, or 1,67,070. This is 1,67,77,000. Okay, 214 number of devices we can connect it. Okay. Small things I didn't do it, but still it is. Someone put a message. Attendance. Okay. I will give you. So we are in the middle. Just present. Sohali, Rohit, Rohan, Priyam came. Vidya came. Aditya.
Sir,
Sir,
Ibrahim Khan.
Aditya present.
Aditya present. Ibrahim. Ibrahim present.
Ibrahim Khan
Gayatri.
present, sir.
Ibrahim present. Gayatri present. Bindu Sri present. Rohan present. I will call missing people, and there is no missing. Missing is Sohali. Rohit came.
Sir,
Yuvraj.
present, sir.
Movika present. Very good. Srija. Yuvraj. And Sohali. 3 members. Let me see. Movika also present. Okay. Okay. So here it is. Once again, we'll get back to the private IP address. It means within your private, as we discussed, the number of size based on number of devices in your network. You can choose any of the private IP addresses. So why I told this entire story? Why? Because of to make to understand these network sizes. Okay. So it is a 1 0 this is one network. This is another network. Each network will provide 254 number of devices we can connect. In this one, this is one network. This is one network. This is one network like this. Totally 16 networks. Each network we are getting 65,534 devices. This is only one network we are getting in this one in a class A. So 10 series. So totally 16 million devices we can connect it. More than 16 million devices we can connect it. Okay. So these are the private IP address, non-routable in public. We can't access internet or public things through this private IP addresses. Okay. So it depends upon your organization, size of number of devices. You can choose any of the private IP address from class A, class B, class C, and you can assign that IP addresses and you can use it. So private IP addresses, you don't need to take a permission from dot or ICANN from your regional APAC centers. You don't need to take any permission to use a private IP address in your private network. Okay, but you want to communicate outside of the network, like you want to access a google.com, facebook.com, youtube.com. So you have to connect it to the internet. To connect it to internet, so you need a a public IP address. So it is within your network, but when you are communicating outside, you need a public IP address. With public IP only, you can connect it to internet. If you connect it to internet only, access. Okay, 1 point. Second, in the same thing. For example, you have a server. For example, a servant is web server is there. So it is contains a website. Okay, website. It is having a private IP address. Within a private, I can access that web server, right? So my web server is in our office. I can access that server from my system easily. No problem. Okay. But how you can able to access? You are in your home, in your own internet, you are sitting. You're sitting in your own network and you're connected to internet. But how can you access the website which is in my office? Okay. My web server is a private in my network. It's in a private IP address is there. You are in your own network and you are connected to internet. But how can you access? So here it is, two options. One is either you will assign a public IP address to it. Okay. Okay. You can't access like you want to access this one. So this system required a public IP. So what you will do? So either you are assigning a public IP address to a server, or you can use a different techniques for that one. Okay. So here is the challenge is first I will go to the my command prompt and I want to show my IP address. ipconfig is a command to check the IP address. So what is my IP address? This is my IP address, my system IP address. My Wi-Fi IP address, right? Is it a private IP or public IP? What IP address my laptop having? Private or public? Check it, private range or public range. It is a private IP. My laptop having a private IP. Don't get confused. My laptop is assigned with a private IP. But I'm accessing internet. I'm accessing google.com, facebook.com. I'm talking to you through Microsoft Teams, right? WhatsApp I'm accessing, YouTube I'm accessing. How can I access from here to there? Okay, but I'm having private IP, but I'm accessing public. How it is possible? There is a two methods are there. One is NAT method, another is PAT method. Two methods are there. Either NAT method or you can use PAT method. We don't know we are using or not, but we are using it. Okay. So NAT, first one is NAT, network address translation. When we are connecting other network, what we use a router, right? To router we are connecting. So router to modem, modem to ISP, ISP to internet. That's the flow, right? Like either your Wi-Fi router or a router. Inside there's either NAT or PAT is configured. So we'll see the NAT first, then we'll see the PAT. NAT, network address translation. Network address translation. What it will do? It maps your private IP to public IP addresses. What is NAT will do? In a NAT means simply it's mapping of private IP address to public IP address. For example, I have a private IP 192.168.1.11. Okay, these are my systems, my servers, my desktop, like that. It is my system's private IP address. I put these things into my router manually. I put these things into my router. For example, I have some systems like this. Okay. And how I will map it? I will map it to some public IP address. Just does not mean it should require last 11 is required, last 1.11 is required. It's not like that. It can be any public IP address. And of course, public IP address, you have to pay for use of public IP. First of all, you have to apply. I need a public IP address. Okay, then you will get it. Okay, you have to first apply, register, then only you will get a public IP address. So in a NAT, it is maps your internal private IP address to external public IP addresses. This public IP address, you have to pay to use of a public IP. Before paying, you have to register, you have to take a permission to use a specific public IP address. You cannot choose your public IP because your service provider from your internet service provider, or maybe from a dot, or maybe you can apply from I can the regional centers. You have to apply. First of all, I need a public IP address, number of public IP address requirement. Okay. And then you have to get the permission. Then you have to pay. Okay. And they will give you this IP address and take that public IP and give it to your ISP, internet service providers or service providers. They will configure in their routers for that communication purpose in ISP routers. Okay, so that is so many things are there, but we'll see to understand what is this NAT. For example, this is 1.11 system, means 192.168.1.11. It is accessing a google.com. So what it will do with this 192.168.1.11, it send that request to your router at a router. Okay, what happened? This NAT translation is there now. NAT, it will convert into this public IP. So earlier it is 192.168.1.11. Now it is when it is going to the public, okay, it is 200.10.1.11 and reaches the google.com. And once google.com receives your request, it will understand your request and what is your IP for google.com is 200.10.1.11 only. Google.com don't know your private IP. It knows your public IP. Next, what it will do? It send a reply. It is sending a reply to your public IP only. That is reaches up to your router. Again, it is translate back to the private IP 192.168.1.11. And where is it is? Here it is located. Okay, it is happened. So already we taken one example, right? You have a web server in your office. Some websites is running. It's in a private network. Private, so from public people cannot access. For example, this is 1.15. Okay, this is 192.168.1.15 IP address is configured for this web server. So from outside, from someone connected to the internet, they want to access my website. Which IP they should use it? My public IP only. With this public IP means 200.10.1.15. So with that IP address, you send a request. I want to see your web page. It reaches up to our router. It translates. It is 1.11, 192.168.1.11 and give it to the web server. Web server see the request and giving the reply to the destination with a private IP only. And again, it is translate back to the public IP and reply will send to the this. It means you are accessing google.com, facebook.com, youtube.com, w3schools.com, tpoint.com, tpointtech.com, okay, tutorial points, microsoft.com, whatsapp.com, web.whatsapp.com are all what we are accessing from using their public IP. internally inside their organization, inside their data center, it may have a private IP also possible. Okay, so this is called a NAT. In a NAT, mainly used for a organization, those who are having a public access related servers or services related, public access based. Okay, so that is a NAT. So actually they will buy a private IP, public IP addresses. Okay, multiple public, it depends upon public connectivity related systems. Internally private connection. For example, I'm accessing a website, the web server connected to a database server. So database server don't have a public IP. They put a private IP, internally private network only. But when I'm accessing web server, that's my front facing, right? I'm uploading my document, I'm filling their forms. Okay, it will take the data and put it into the database server. But my interface is my connectivity from my laptop to that one is a web server. That is, it's a connected to public wise. Through NAT or directly, it's a public connection. But internally, inside an organization, the database server should not require to be connected publicly. Internal connection is required. Then it is backend, it is private only. Okay, this is very important if you are in case you are learning CCNA kind of stuff, when technologies you are working, or you want to learn about cloud computing, cyber security. This concept is very important. Of course, there are a lot of explanation videos also available. You can try those things when you got a time. Okay, this is a NAT. NAT means internal private to external public IP address mapping. Internally, we are using private network, private wise communication. For example, this is 1.2, means 192.168.1.2. Want to access this website, it is used 192.168.1.15 is enough. Not required public IP. But this system is accessing in the internet, that system is accessing our website. This it use public IP only. Guys, understand the part? NAT. As I said, there is two things. One is NAT, another one is PAT. Another one is PAT. What is this PAT? Port address translation. It is also called as NAT overload. NAT overload. In the NAT, it is one-to-one mapping. One private, one public. One inside network, one inside IP address, one outside IP address. So this is inside, this is outside. Inside, this is outside like this. So don't go to inside and outside. So there is a lot of complex statements. So internally, so in our in organization, it is both are inside only actually, but inside private it is. This inside public like that the people use, but private and public. Internally, we are using private. When we are communicating out, then we are using public IP. One-to-one mapping type. One private, one public, like that. For example, you have a 10 devices. You want to connect it to public. 10 public IP addresses are required. Think about in your home, how many devices accessing internet through your Wi-Fi? Your smart TV, your laptop, your mobile phone, your brother or sister mobile phones, their laptops, like your parents' mobile phones, tablets. So around at least 10 devices are there to connect, right? So are you going to buy a 10 public IP addresses? Anyway, we can't do it now. For every device a public IP is, we can't fulfill it. So then it is the technique comes a PAT. Okay, so in a PAT, it is port address translation, NAT overload. In a PAT, what we will do, we map multiple or all private IP address to single public IP only. So it is private IP address are different, changing. But public IP address, you see, it's the same public IP for all the devices. But how it will possible? It is a dynamic port mapping is there. Means if I open a google.com, to my private, a port is added and send request. And that again mapped to my public IP. So my request is completed, done. Then entry will be removed. Again, as I open something, then again my IP, my private IP, a port, random port, and public IP, my public IP, and that same port it is added. So like that. So using a port mapping, we can use a single public IP address for all our private IP address communication. Okay. So this is called a NAT overload. In NAT means 1-to-1. PAT means all to one. So that's it is NAT overload. NAT is mapping 1-to-1. So we are overloading on a NAT. So all to one. So that is why it is NAT overload as a PAT technique. Guys, we are all using a PAT technique. We are not configuring it, we didn't see it, but what is actually happening is PAT only. The public IP address you are not buying, but still you are connecting. How it is possible? Your ISP, Internet Service Provider, will do the translations in between from your system to your router to their ISP to outside of ISP. This number of translations will happen. Okay, you want to know your public IP? Okay, you want to know your system IP address, IP config or IP config all, right? Check it. What is your system IP, your adapter IP address? Okay, command wise. You want to know your public IP, so simply type what is my IP address. If you type like this, simple, in the Google, it will show some IP address. That is your public IP. And you go to other systems, those who are connected to same network, same Wi-Fi network. Same Wi-Fi with the 10 systems. Almost all, every system having same public IP only. So what happened? We're all connected through one single public IP to communicate outside. Okay. So what about the security? Okay. What about it? Guys, where we use NAT, where we use PAT for home, small offices, for our desktop, laptop, mobile phone, internet services, because we are not giving any service from our device. We are accessing google.com, facebook.com to our system. Okay. So definitely. Okay. We are not accessing google.com. We are accessing google.com, facebook.com, youtube.com. But we are not having any web server to get access from outside. So it is inside to outside. We are sending request and we are getting reply from outside to inside. So then we are using PAT technique. Okay, PAT technique in our home or offices. But if you are in office, you are having a servers. It's a public-based connectivity as a web server or authentication server, VPN servers. Okay, or maybe there is a what is a FTP server like that. It is mail servers. So it need a public connectivity. So what do we do? So we follow the NAT. NAT is a permanent mapping. Means private to public, a permanent map is there. Outside people communicate with the public IP address, then we reaches and it is again changed to private IP and get connected. Where we use NAT. Okay, because we are providing services. People are accessing our systems from outside. Then we follow the NAT. Okay, next. So as some people concerned about a network security. Yes, of course, you are sitting in a something like free Wi-Fi zones. Like earlier days, we have a coffee days. Now still we are having that kind of things or not, we don't. So you go to that kind of shops like you go to coffee shops or maybe railway stations. We are all connected to same free Wi-Fi network. Even there is a limitation like a 30 minutes and all. But we are all connected to same network We don't know who is connected to that network. So definitely there is a possibilities there. But in your home, you know which devices are connected in your home, to your Wi-Fi router. So there is a no problem. Next is PAT. Again, PAT. Guys, someone knows your private IP, they can't reach you. Someone knows your public IP also, they can't reach you directly. Because of this same public IP is used for different systems. In a PAT, you can access things from outside, like google.com, facebook.com, you can access it. But google.com want to access your system. They can't reach you. Even they know your public IP, they can't reach you to your system. If someone knows your private IP from through internet, they can't reach you because private IP are non-routable. Same IP is assigned for so many number of devices in the globally. Okay, that is main. Public IP. In a PAT, same public IP used by multiple systems. Someone knows your public IP, they want to reach your system. Whose system? You are already having multiple systems, so they can't reach you to your system directly. Okay, so it is automatically a secure transfer. Yeah, anyway, I took a lot of time and this is NAT and PAT. I want to give a break, but no break. So I will complete this part. Okay. Otherwise, take small break, guys. Very small break. Just relax. First process the information. So back at 11:20, just a very small break. It is 11:20.